everyone, and welcome to the last of the GCSE live streams. It's Unit 2 tomorrow morning. I hope we're all really excited. Judging by the comments in the chat, people are a bit apprehensive rather than excited about tomorrow, but never mind, you'll do fine, I'm sure. Now, as we've seen with the exam so far, and I've said to you before, the WJEC are saying to us no surprises, but what they've actually done is given us some surprises. So let's look forward to some surprises tomorrow. Now, the only other exam we've had similar so far is the AS level exam, where they have a practical exam. And that was a very, very straightforward exam. So I'm keeping all my fingers crossed that you guys get the same sort of treatment. A nice, straightforward exam would be fantastic for us. But you're going to be in an exam in a computer room for 2 hours tomorrow, maybe more, because traditionally, when you start the exam, the WJEC's website goes down. So you have to wait for it to come back up. So maybe longer. Prepare yourself for about 2.5 hours. And you are going to be trying to build a bunch of software and answer a question on an electronic answer document. But before then, let's do a bit of revision and get started. So what I will say to you is, please, I've put this in the chat a few times, but if you haven't got there so far, please go to my website, go to this address, lessonhacker.com/unit2, where I've put a big bunch of resources for you. I'll just jump over there. I've got them in the order that I'm doing them tonight. There's 3 scenarios in HTML that are linked to REPLs. If you've not used Replit before, it is pretty good. Basically, you get to this page, you might have to sign up, click the fork button, and you'll be in a place where you can start working on the code and getting it to work. Within that, I've also embedded the PDF of the questions and stuff like that. So if you are going to go and do a bit of revision, it's all there. I've got my videos on assembly language, which I'd recommend you watching at 2x rather than 1x because you haven't got that much time. All the past paper questions for the algorithms are there. A big bunch of Greenfoot stuff. If you haven't got it installed at home, the correct version of the Windows and Mac installers are there because it's an old version you need, 2.4.2. I've also got a revision sheet here, which is absolutely brilliant. And I'll talk to you about that in a minute. I've also gone and made myself the ants question from 2019. So it actually works on the right version of Greenfoot, which hopefully will be better, and the question sheet, as well as my video walkthroughs of a previous scenario of the 2019 past paper and my video series. That video series is a little bit old now, but it is still worthwhile if you are none the wiser. What did they change about this unit for 2022? Absolutely nothing. They did take away your NEA and they did reduce the other unit. So we have nothing to reduce this time. So that means we've got the entire syllabus to cover tonight. Greenfoot, as you imagine, is last. I'm going to try and get through everything in an hour. If we run over a little bit, we'll run over for a Greenfoot demo because that is probably what everyone is hating at the moment. Let's start with HTML because it's one of the most straightforward things. This is literally a screenshot from the specification. So it's the guide to what you guys should know. And it's the list of HTML tags that you should know. Again, on the website I linked you to earlier, that list of tags is on there that you need to know. Now, aside from the ones here, you also need to know the tag U for underline, because they sometimes ask you to do it, even though it's not there. And you do need to be aware that these bottom 2 tags do not have closures. So the rest of the tags are quite straightforward and self-explanatory, and we'll do a build of the 2019 past paper together in a moment to practice those. Your HTML tag tells the entire page this is a web page. So the entire page must be wrapped in an HTML tag. The head is the invisible part of the page. This is the metadata. This is the information for search engines, for the browsers. Anything that goes in there isn't actually displayed on the screen. So please remember that. The head is stuff that isn't displayed on the screen. Title is part of head. Title is the bit that would appear on the tab at the top for the web browser to know what your page is. Everything else needs to be in the body. And yes, computer scientists are comedy gold. Head, body. Head's the invisible bit. Body is the bit you see. And within that, we've got heading tags. I've never seen it ask you for anything more than an H1, which is the biggest heading. A P is a paragraph. All chunks of text should really be wrapped in a P tag. The I tag is for italic. The B tag is for bold. The center align tag is center ER spelt in the American way. It will not work if you spell it in the British way. And remember, you can put multiple tags in a center tag, so you can center a lot of it. Links to websites are in this format, href, and then inside the speech marks, you need to put the full website address, including http://. If you don't, it won't actually go to the site. So there are 2 marks for a link. There's an email address where you just stick mail to and colon and then an email address in the same way as a hyperlink. Your unordered list is your bullet points. You need that to wrap the list, and every bullet point must be within an li tag, a list item. And a block quote is like a quote, basically, from somebody. I would be surprised if you had a question that involved you making a quote, because they basically don't look much different to normal text. These final 2, the HR, the horizontal rule, a line across the page, and IMG, do not have closure tags. They only have the opening tag. We're going to try and build this. This is the 2019 past paper, trackmypetcare.com. And this is how the question was presented. We had that page on the left there, and we've been asked to recreate that. Now, before we jump into it, I just want to point out some really important things from the question paper, which you may not have done at home or with your class. First of all is the bottom. The page title should be set to Track My Pet Care. That is the bit in the head. That is the invisible bit. That is worth a mark on its own. And then the most annoying thing about the WJEC's way of marking this is that I cannot save my file as a .html file to send it in. I need to save it as a .txt file. I don't know why. I really don't. I wish I did, but that's what they want, and that's what you should do. I do not know whether they would refuse to mark it if you named it wrong, but it's better to be safe than sorry. Let's have a go. So I've got a few things open here. I've got Chrome or web browser. I've got my text editor. You will likely be using Notepad or something like Notepad++ in school, and the question sheet. Now I've got the question sheet up so I know what I'm doing, but also because I really want to make sure that I am able to copy and paste the text. One of the things people waste time on every single year without fail is they spend their time typing this text out. We are going to copy and paste absolutely everything that exists there. And the first thing I'm going to do is save my page so I can open it. File, save as. Notice there's absolutely nothing in there at the moment. Now, I'm going to give it a name. So I'm going to call it my page. And importantly, then you need to give it an extension, .html. Now, you could give it .htm as well. It doesn't matter. You cannot submit this version to the WJEC, but you need this to be able to work on it. Once I've saved that, I now need to open that in my browser. Now, the easiest way to do that is to find the file, which I apparently have managed to lose. So let me grab that. What have I called it? mypage.htm. And I'm just going to drag it over here up onto my tab and release it there. And that will open it up. Now, the method here is this. We are going to put our code in on the left. We're going to click save. We're going to go over to our browser and click refresh to see what's happened. Big warning. The web browser is designed to ignore as many errors as it can. Yours might look right, but your code might be worth 0 marks. So you have to be very, very careful with how you build this. Let's start. The first thing you need is HTML. Okay. In Notepad, this won't highlight, I doubt. Notepad++ it will. Now, one of the good habits you should get into is when you create an opening tag, leave a bit of space between it and create the closing tag. The closing tag is the same. It's slash, forward slash, and then the tag itself. This basically says, this is the start of my web page. This says, this is the end of my web page. Then I need to add my head, my invisible part. Again, I'm going to make a bit of space, and I'm going to put my closing tag within that. While I'm here, I'm going to make my body tag. And just down here, I'm going to close it. Remember, my body stuff is the visible stuff. The only thing that needs to be in head is the title, opening tag, closing tag, and we know what our title is. We talked about that a moment ago. It's Track My Pet Care. You will have the PDF of the question paper in your exam. Please copy and paste it so you don't get any errors with the text. That is a very basic, straightforward page, and I'm going to save that. I'm going to refresh over here. Now you'll notice straight away, hopefully, if I can zoom in here, that Track My Pet Care is now the name of my tab. That is because I've put it in the title field here. And that's a really important thing. That's worth a mark. In fact, this entire page so far, even though it doesn't display anything, is worth 1, 2, 3, 4 out of whatever the total is. And that is out of, let's have a look. I haven't put the mark on there, but that is worth 4 marks on its own, and there's no content on there yet. Okay, so next thing, I've got a heading and a picture here. They both appear to be center aligned. So my first job will be to make a center tag. Don't forget, it's spelt in the American way. I'm going to leave a bit of a gap because I need to put both a heading and a picture in my tag. First thing is going to be the heading. Now, it looks like a H1 to me. Put the heading in. Put your closing tag in. And then between those two, paste in heading. Save it. Refresh. Boom. Looks pretty good to me. People asking, do they need to use center tags? Pretty much yes. Nearly every year, some part of the page has been center aligned. So you do need to use center tags. As well as that, you'll see, and again, you can get the hint of this if you highlight it. It looks like those two things are centered and the rest of them are on the left. So I need to put my image in centered now. Now, first things first, make sure you have this saved in the same place as your image, because if you haven't, this isn't going to work. So I'm just going to move my image into the same folder. Hopefully. There we go. Now, my image is called, I think I've got it down here somewhere. There we go. Pets.jpg. So JPG. JPEG. So we need to put that image tag in. Now, an image tag doesn't have a closing tag, so we don't need to worry about it. And the way it works is we do img as in image, space, src as in source, equals speech marks. Close your tag. Now, within those speech marks, then I'm going to paste the name of that picture. And I'm going to come up here and refresh. And that looks fine to me. Looks broadly the same as that one. One extra hint, if you put your image in and it's so huge that it looks ridiculous, you won't get any marks for this bit, but you can change the size of the image within the image tag by just putting a space after the name and doing width equals, and then putting in a number of pixels. If I set it to 100, I refresh, you'll see it's got a bit smaller there. I don't need that in this particular one, but in some of the past paper questions, so I'm going to save and refresh. In some of the past paper questions, the images were absolutely huge, and you needed to do that just to be able to see the page. They wouldn't mark you down for it being huge, so no need to worry. Now, after this point, I've got everything that's left aligned. So I'm going to go outside of my center tag, just make a bit more space so I know where I am. My first line of text is a paragraph. So paragraphs go inside P. Paste that. Close your paragraph tag. Save, refresh. It looks good to me. Now, you might be thinking, oh, this is squashed over a little bit. But if you were to make that window the same width as the box there, you'll see that it looks more or less the same, more or less. Don't worry too much about it being exactly the same, because the point of a web page is meant to render differently on different pages. Okay, I've got an unordered list here. I'm going to just copy those bullet points. So we need unordered list, make a bit of a gap, close the tag. Every item in the list now, these things, each of those items needs to have an li before it, and at the end, a closing li tag. That means a list item. That means that it will end up with a bullet point before it. Don't forget, you're probably not likely to have the syntax highlighting like I've got going on here in Notepad, but if you're using Notepad++ or something like that, it would work. Okay, there's my unordered list. That's what that is. And we've got it working. Another bit of text, that's just a p tag. You notice that what I'm doing is every time I put a little bit in, I'm just refreshing it over here to check it's okay, and it seems to be all right. And my last one. Now, my last one is a hyperlink. So it's there is a difference between being right in the exam and being right in real life. In real life, I put a p tag in, then I put this text in. But in the exam, we don't need to. So I'm going to do this. A space href equals. Now, href stands for hyperlink reference. Everything between this tag and its closing tag will become a hyperlink. I'm going to copy that text and put it there. This is going to be my hyperlink. If I save it here, you'll see that it's in there, but I wouldn't get any marks for this because there's no website address. In the speech marks, I need to do two things. I need to paste in my website address, and I need to go back to the beginning before the www and add this http://. You need to know that. You need to remember that, because the HTTP bit is the bit that tells it this is on a separate website and this is the website address. Without that, it would try to go to this address on your website, which would be weird. There we go. If I hover over it, you'll see there that it does say that it is going to take me to trackmypetcare.com. That website doesn't exist, or at least it didn't before. I'm frightened to click on it whilst I'm doing a live stream because goodness knows what's actually happened to it. Now, at this point, I'm done, but not quite. Not in the position where if I submitted this, I'd be confident I'd get a mark. We've been asked to save our final piece of work as this, finalpet.txt. So I'm going to go File, Save As. I'm going to call it finalpet.txt, click Save. Notice when I did that, all my highlighting went off. It now thinks this is a text file. I can't run a text file in the browser. So this is done, but you only do that last. That's the last thing you should do in the entire setup. But there's your HTML. The rest of the tags, as in here, you will need to go and have a play with. Put them in, just see what they do. But they're the ones you need to know. In the 2019 exam, they also asked you to name the tags that did different things. So you do need to understand them. Once again, HTML for pets, which is the 2019 exam paper, 2019, the old spec, and the 2018 past paper questions, which are very, very similar to each other, are worth practicing in time before tomorrow if you have the opportunity. Okay, assembly language next. Now, assembly, as many of you know that have watched my videos on this, will know that it's one of those topics that I think they will find it difficult to ask you questions about, because the instructions they've given you, these ones, and these are mnemonics, by the way, they're shortened versions of the actual instruction. So it's 3-letter representations of the instruction. Most of them are straightforward. INP is input, OUT is output. STA, you might think, why is that store? Because it's short for store into the accumulator, and load is the same, load into the accumulator. Sorry. We've got add and subtract, branch, which is basically go to a different line, halt, which is stop, and dat, which is that there's data there. These are the instructions you need to know, grouped into the categories. Okay. In A level, you have exactly the same list of instructions, but there are 2 more branch instructions that allow you to go somewhere else only if something is true. Without those instructions, all you can build is a simple project or a ridiculously complicated infinitely looping project. I think they've shot themselves in the foot a little bit by doing this, because the types of questions they can ask are therefore limited as a result, but they could do. And I'm going to show you an example program. This is a times table calculator. So your times table, as you'd imagine, is the 5 times table is going to output this sort of thing. This is assembly language. These are the lines of code, and these are also the memory addresses. We've got a few things you need to know about. The program counter up here always points to the next instruction. The accumulator is where the answer to any mathematics goes. And we're going to follow the fetch, decode, and execute cycle as we go for this instruction set. You may be asked to interpret this program. You may be given this code and asked to go through and dry run it. In other words, write it out in a table. You might be asked to edit that, to point out what's wrong with it. There's a bunch of stuff that they could do with the questions on there. But let's go through and see what it does. So if I'm running this program, we start by initializing the program counter to 1. And the first part of the fetch cycle is we get the instruction from location 1. That comes down because we've got the instruction now, and notice that our program counter increased to 2. It always points to the next one. Decode is understand what it means. IMP is input. We ask the user to type in a number. They've typed in 9. We stick it in the accumulator. Happy days. That instruction's done. We go back to fetch then. We look at the program counter in the corner and we say, actually, I'm over the program counter. Apologies. Ooh. No, I'm completely off. Oh, no, I am on. Right, sorry, I managed to turn my screen off that I was looking at. Right, where am I? Right, let me put myself in a proper position. That is better down there, I think. Right, there we go. Sorry, so the program counter is always pointing to the next instruction. At fetch, we go and grab that next instruction. So we go into line 2, and then we increment the program counter. So it's pointing to the next instruction. We decode it. STA7 is basically store whatever's in the accumulator in line 7. Line 7 is this line. So that 9 is going to go into that. We've done that instruction. Next one, we fetch. We go into line 3 next. We load from line 8. So that's what decode means. So what's on line 8? It's this 0. Let's load it. Where does it go? Well, it goes up into the accumulator. We've got the accumulator set to 0. Next job is to add 7. Now, this one confuses most people. We're not saying add 7. We're saying add from location 7. And that's the really important distinction here. We're adding from location 7. So we're adding this. We're doing 9 plus 0. The answer, of course, is 9, and that goes back into the accumulator. Our next thing is out. That's output. It's going to show whatever's on the accumulator on the screen. So we're going to get a 9, and then we're going to go to our branch instruction. Now watch what our branch instruction does, because fetch does the normal thing. It goes to that instruction and increments the program counter. That's set to line 7. We're going to decode that instruction now. So we're going to work out what's going on with that one. Branch means set the program counter to this value. So let's do that. Watch the program counter. It was on line 7. It's now line 4. So that means the next time we get to fetch, we look into the program counter to see where we're going, and we get pushed up to line 4. Next thing is to add from location 7. So that's 9 plus 9. That's 18. Goes into the accumulator. Output that on the screen. So we're getting our 18. And then we branch back to line 4. We set the program counters to line 4. And the next time we get to fetch, we get taken back up to line 4. Once again, add from memory location 7. That contains a 9. So that's 9 plus 18. That is 27. Output that on the screen. Great. And then branch back to line 4. And that is setting the program counter to line 4. And the next time we fetch, then the same thing's going to happen. Now, you probably don't want to be doing that forever, because the only program we can write here is an infinite program. But that's pretty much all it is. You might need to interpret, you might need to understand the mnemonic. This labels is not part of your specification, but I could see them dropping it in because it makes programs a little bit easier to read. So this is the same program with labels, just to give you an idea of what they are. Now, again, this is not in your specification, but it is reasonably straightforward. I could see them doing it. What's happening here is on the left, they're labeling certain lines. And instead of having to give line numbers, then you can give the labels. So this means store it in the table, which is line 7. This means load it from the start, which is line 8. And that's really, when the computer does it, it goes through and replaces those with the actual line numbers. So the program is identical. It's just a bit easier for humans to read. So just be careful of that. Now, I would strongly suggest you go and watch my video. If you don't watch any of my other assembly videos on YouTube, go and watch the one called Skills for Exam Questions, because in it, I've made up a bunch of exam questions for the various different types that I think you could get, and I go through and show you how to answer them. We haven't got time for that tonight, because the only examples of this question we've ever had are, what are the mnemonics for add? Well, I wonder what a surprise that would be. Again, on the website, lessonhacker.com/unit2, the link to the full playlist is there. If you click on that or you click on the link, you'll be taken to the YouTube playlist. You can find that video. It's the last one in the playlist. But if you want a bit of a recap of that, I go through everything in ridiculous detail there. Remember, do watch it in 2x rather than 1x. Searching and sorting algorithms now. These are what you need to know. Sorting algorithms, you need to know merge sort and bubble sort and the characteristics. So what they are, how they work, what's good and bad about them. And for searching, you need to understand linear and binary search algorithms. Okay, so here's linear search. Linear search works on unordered data. So if the data is in a random order, this works fine. Let's imagine that I'm looking for D. What I do, I start in the first position and I say, is this D? No. I move on to the second one. Is this D? No, it's not. Let's go to the next one. Is this D? Oh, it is. Score. So we return the index. Now, linear search is great, but if this list was 40,000 items long and the D was in item 39,998, we would have to go all the way through it until we found that. And that is really, really slow and boring and is going to take you the rest of your life. So there's a better way. If you can get the data in order, we can do binary search. Binary search means we find the midpoint. Let's call that the midpoint. And we say, is this D? Well, it's not. But from that, we can ask a second question. Well, is D less than or greater than C? D's on the right-hand side. It's going to have to be. If all we know is C, we know D's on the right, which means we can ignore half the list. We've essentially Thanos snapped half the list away there. We go to the midpoint of what's left. Is this D? Well, it's not. But D comes before E. So I can ignore the right-hand side. Finally, oh, I found it. Now, it took 3 steps, but it halves the list every time. In that 40,000 item list, in one search, we'd get rid of 20,000 things. The next time, we get rid of 10,000. The next time, 5,000. It would take significantly less to work on a divide and conquer search algorithm like this than it would on linear search. Theoretically, they could ask you to code that in an exam. I think they'd be very mean if they did. Linear search is probably the most likely. And all you'd have to do is go through the array one at a time and see if the item is in it. If you want a bit of a recap on that, I've got a YouTube video called Thanos's Binary Search. Go to my YouTube channel, have a look at it. It's a bit of fun. It'll remind you and go over that topic and give you some more characteristics. Bubble sort then. Bubble sort is great for sorting a set of data, but it is very slow. The idea is this. We're going to go from the left to the right and looking at all the pairs. If any item in the pair is the wrong way around, we're going to swap it. If we have to do even one swap, what that means is we'll have to go from left to right again once we've got to the end. And if we can go from left to right, then if we can go from left to right without doing any swapping, we're done. So let me give you an example. We start here and we say, are C and A in the right order? Well, they're not. A comes before C, so we swap them. So because I've done a swap, I know that I have to go back from left to right. We move on to the next pair. C and D, they're fine. B and E, they're fine. E and F, they're fine. F and B, well, they're the wrong way around, so we switch them around. I'm at the end now, so I made at least one switch, which means I've got to do it again from the left-hand side. We fast forward a little bit because it'll take ages to animate otherwise. This sort of starts happening, and you'll see that the higher numbers start bubbling towards the right, which is why it's called bubble sort. It is the slowest sort in the world, but you need to know what it is. Okay. Merge sort is a bit nicer. Merge sort's very, very straightforward. You're going to split the array into individual elements. Now, individual elements by default are already sorted. If they're a set of 1, they're already sorted. There's nothing higher or lower than it. And then what we're going to do is pair them up. Now, in each of the pairs, what I'm going to do, I'm going to look at the left and the right, and I'm going to start bringing down the smallest value. So in this case, I'm looking at C and A. A is smaller than C, so I'm going to bring that one down first. Then I'm going to bring C down because that's all that's left. And I've got a sorted group. Same with F and E. E is smaller, then F. That's sorted. And then D and B. B is smaller, and then D. Now, we're not there yet. We have to do that same thing again, but to these sorted groups. So there's an odd number, so I'm just going to do it on these for the meantime. Now, what we're doing is we're looking at the leftmost value. okay? The leftmost value here. We're looking at A and E, and we're going to say which one's smaller. Well, A is smaller, so we're bringing that down. Then we're looking at the leftmost value of both sides. So now we're comparing C and E. C is smaller, so C will come down. And then I can bring down E and F. And I've got now a sorted set. Pair up these sorted sets and do the same thing. And remember, I'm always looking at the left and right hand side. Is my audio working or not? Let me have a little look. Sorry. 1, 2. No, it seems to be working okay. I'll keep going. So what we're looking at here is we're looking at the leftmost item of each set. A is smaller, so we're going to bring that down first. Then we're looking at the leftmost item on each set, C and B. B is smaller, I'm bringing that down. Then I'm going to look at C and D. C is smaller. E and D. D is smaller. At this point, I've only got one left. I can just bring them down. And we've got a merged sort. The nice thing about a merged sort is that you can do this in place. I think it would be very unlikely you'd be asked to write this algorithm. They don't even ask our A-level students to write this algorithm. It is very complex to do that in any kind of code in an exam. I think if you were to see this, they'd be asking you a written question to describe the differences between them and how they work. Or they'd expect you to spot that if they gave you the pseudocode. They give you the pseudocode for a sort and go, what kind of sort is this? If it's going from left to right all the time, it's bubble sort. If it's pairing things up, it's merge sort. Okay, algorithms now. This is quite a big topic. First of all, you need to be able to read and express algorithms in a standard form. So you may need to understand flowcharts on the left, where you've got your terminators, your start and your end connectors. They're these rounded rectangles. You've got your processes, your rectangle there. That's something it's doing in the background. You've got your decisions as a diamond, and you've got multiple arrows coming off there with text on them. Subroutines, in other words, there's another diagram that represents that. These are labels, and the one I've missed out is a parallelogram, which is input and output. You might also be asking for this sort of thing, which is pseudocode. Now, pseudocode is sort of plain English code. It's designed, well, the WJEC designed it to look a little bit like Visual Basic. And for all of you that are watching Visual Basic, who have learned Visual Basic in the process of your GCSE, I'm sorry. I'm very sorry. Those of us that learn proper programming languages that the real world actually uses. Anyway, pseudocode, you do not have to write this in the exam. If they ask you to write code, you can write in anything you want. You can write in something that looks like Python, something that looks like Perl, anything you want. But the important thing is that you do need to be able to read it. And it is reasonably straightforward. If you have a look at the examples we'll look at tonight, they do make some sort of sense. The important thing is, can you make sense of what it's trying to do? I'm going to go through now the list of things you have to do, and we'll try and explain them. First thing, identify, explain, and use subroutines. So a subroutine is a subprocess. It is a function, or it is a definition in Python. It is where we've got a small program that can be called with variables to do something else. This is a subroutine in pseudocode, and you'll see very happily they say declare subroutine. So it is quite easy to spot them if they give you pseudocode and say, where's the subroutine? But you can see that what it normally does is it outputs something or does a bit of a function in the background. Identify, explain, and use sequence, selection, and iteration. Sequence is the order of the instructions, so it's the order of the lines of code. Selection is your if statements, and iteration are your loops. You need to be careful with all of those. Identify, explain, and use counts and rogue values. Now, a count is where we were able to instantiate a variable before a loop and count how many times something happens. Straightforward. But a rogue value is weird. A rogue value is where if we write a subroutine that's going to work out an addition, for instance, if something goes wrong, rather than sending back an error message, we send back a value that makes no sense. In most cases, this would be sending back a minus value or something like that. So you've got to be careful that they don't ask you about that, because that idea of rogue values appears exactly once in this syllabus there. And that's exactly the sort of question that they might sneak into an exam. What's a rogue value? It's where we return a number that shouldn't exist in the answer to show that there's been an error. Identify and explain constructs in object-oriented program. A construct, something like a for loop, an if statement, it is a classic way of producing some code. Follow and make alterations to algorithms and programs that solve problems using sequence, selection, iteration, input, process, and output. So basically, can you read programs and can you change them? Write algorithms and programs that solve problems using sequence, selection, Can you write them from scratch? We'll be doing that in a minute. Variables. Now, this is an interesting one. Identify, explain, and use local and global variables. So there's a difference. I've got a bit of code here where there's a local and a global variable. First thing, here's our local variable. Now, it's a local variable because it has been declared within a subroutine. That means that that variable only exists inside that subroutine. And the same thing can happen in a loop, or the same thing can happen in a different kind of construct. But a global variable, as we've got down here, is a variable that's been instantiated within the main body of the code. And what we're doing with that is that code will be accessible for the entire run of the program. And we call this idea scope. Scope is how accessible that variable is. These local variables can only be accessed for that part of the code, barely by anything. These global variables can be accessed by all of the code from the moment they're instantiated. This code comes from an A-level question where the students had to write down the outputs. And the idea was that they should have written C and D as no value, because you can't output C and D if the scope doesn't allow you to. And that's pretty much what they were doing with that. You want to use local variables as much as you can, because local variables, you can set standard names for them and they disappear, and you can reuse those names as much as you want. Global variables you want to avoid, because in long code that can become problematic. Okay, self-documenting identifiers. What are these? Self-document identifying identifiers are good variable names that make some sort of sense, not just X and Y and A and B. The only exception to this is you can use I, J, and K for loops. Annotations is comments. Comments are important to explain code to you or other people. Certainly, you would need to do it to yourself. String handling. Okay, things you can do with strings that they might ask you about are probably things like concatenation, so joining strings together, maybe doing string slicing, chopping out individual letters or individual chunks of it, and then worrying about text in that regard. Math operators. All right, so this is a little bit fussy and people often get mistakes here. Here are the basic mathematical operators. We've got plus, we've got divide, it's a forward slash. You've got multiply, which is an asterisk. You've got minus, which is a minus. And then you've got mod and div. Now, these are short for modulus and divisor. What a modulus is the remainder of a division. And that's really important you know that, because that has popped up on multiple papers this year. So I think the examiners really, really want to test that everyone knows what mod means. Mod divides one number by another, but instead of giving you the decimal answer, gives you the remainder. And this is really good because we can find out if one number is completely divisible by another, because it would come out as 0 in a mod. There'd be no remainder. Div is the opposite of that. It gives you the whole number remainder of any of this data. So div, the divisor, gives you the whole number. So they're the standard mathematical operators you need to know, as well as these comparison symbols. You've got less than or equal to, greater than or equal to, greater than, and then two variations on not equals. Either this one, which most people that know decent programming languages know, which is exclamation mark equals, or this one, which you'll know if you've done Visual Basic. The two less than and greater than operators pointing in different directions are not equal to. Sorry, people are saying, are there any revision sessions before the exam tomorrow? Yes, certainly for my classes. I'll try and get in as early as I can. It'll definitely be before 8 o'clock, so I can give you a bit of time before the exam. We'll do it like we did last time, just in the room where the exam's happening, which will be H05. The last symbol to remember is that equals, if you're comparing something, is a double equals. And that's really important. Logical operators then, the ones you need to know about, and or not, an exclusive or, XOR, just like we looked at last time, you can combine if statement conditions with those. So if something and something, if something or something, you could say if not something. So you have the opposite of the if statement. It's a bit weird to do that, but you could. And then you could do if something XOR something, an exclusive or. Only one of them should be active, not both. I've never seen them ask a question about that, but again, you could. So with that in mind then, sorry, 1 second. Thank you. Right. Sorry. These logical joining symbols. Okay. We did those in truth tables last time, so they should be straightforward. I'm skipping sorting and searching because we've done that. Testing and evaluation. You might have to say how good an algorithm is, how good a program is. Does it do everything that you want? Great. The efficiency of an algorithm is like how well it does it. Are there wasted steps? You might need to look at that as well. We've not seen any questions on those ever. Problem solving, I'm not even going to talk about this because what this relates to is this question. And this is the algorithmic design question. Now, what you have to do from this, and there's one every year, they're very, very similar, is you have to write an algorithm that doesn't necessarily need to work. No one's asking you to write this in pure Python, Visual Basic, or Java. You can write it in pseudocode, in structured English if you want to, or plan it out. It is an algorithmic design, but what you do need to do is write the code to answer these questions. And it repeats itself every year. More or less every year, we have a bunch of skills that we need to do. In this example from 2019, they've asked you to enter 4 meter readings and then to work out the total, the mean average, the largest and the smallest value. This question has some hints in it. And for 6 marks, roughly speaking, there's a mark per bullet point here. So even if you can't get this done, having an input and an output and maybe an if statement in it would be brilliant. Let's do this question. But before we do, let's have a look at the usual skills that are repeated. The sort of things that you probably will get asked year after year after year. You'll need a loop to take in the inputs. You'll need to instantiate the counting variables, so start them off at a value that's sensible. You'll need if statements to find the highest and the lowest. You'll need to calculate the average cost and then output everything. Well, let's go and do that. Here's my question. Here's where I'm going to write it. You can write this straight into Word. You will have a Word document that you type in your written answers in. Let's get cracking with this. First thing, we need some kind of loop to take in the readings. So I'm going to leave a bit of a gap at the stop because I haven't instantiated anything yet. So we'll do that in a moment. So I'm going to just do a for loop, and I'm going to do this in Python. For I in range 4. That means I'm going to loop 4 times. Of course, whatever syntax you want to use, whatever language you want to use, up to you. But we need a loop that loops 4 times. And in it, I'm going to do something like reading equals int input. And then I'm going to copy the text directly from here because I want it to look as close to that as possible. Enter reading. Now, what that's going to do is going to do that exact thing. So my inputs are done. The next thing I need to do is instantiate my variables because I need to work out a total, the mean, the largest, and the smallest. So I'm going to instantiate all those up here. Total is 0. Mean is 0. So I'm going to work those out. And then my top tip, if you have a largest and smallest, you instantiate those, you start them off at their opposites. The question says that the smallest number I will have is a 1. So I'll set that to the largest value. And the largest value I'll have is 10. So I'll set that to the smallest value. This is a really, really important thing. It's the big top tip because what I'm going to do in a minute is have an if statement that compares the reading to the largest and the smallest. Therefore, if I'm getting a number smaller than 10, it will become the smallest value. That's the only real way to do it, but we do know what the biggest and the smallest numbers are from the question. Okay, next thing is starting the calculations. The total plus equals reading, adding to it each time. The if statement for the largest and smallest. If the reading is smaller than the smallest, then the smallest becomes reading. I'm not going to put an else here. I'm going to put another if, and that's important as well. If the reading is greater than the largest equals the reading. And again, all this is really important here. It's important that they're both two ifs, because the first number they type in will be the biggest and the smallest, and we don't want to get confused with an else. Final bit. I'm going to go and indent myself all the way back here now because I need to work out the mean. The mean is going to be the total divided by how many numbers there are. There were 4. Got all my work calculated. I'm going to print things out now. I'm going to print total, and I'm copying exactly what it is over here. Comma, total. I'm going to print mean, comma, mean. I'm going to print largest. I don't know if I can spell largest. Again, my variable names are sensible here, so the examiner can understand it. Smallest, smallest. And you've got a program worth 4 marks there. If you don't remember the syntax for something, let's say you forgot how to write add reading to total, you could literally just write add reading to total in plain English, and you would be able to get a mark from that. Because the way you answer it just needs to be in a standard form. One of those forms is structured English. So if you can't remember programming syntax, I want you to try your best for me to write it in a way that makes sense, but just a programmatic way, and you'll be good. Okay, with that done then, all the past paper questions on this topic, the algorithm past paper questions, are in a zip file on that website. That link there will take you to it. It'll have the question and the mark scheme for you. You can practice these a couple of times. It is almost certain this question will come up in some form. They tend to almost be the same every year so far. It's worth taking a look if you can. Concepts. Now, these are ideas that you need to know a little bit about. One-dimensional and two-dimensional arrays. Let's have a quick look at those. Files and records are straightforward. A file is a collection of records, and a record is basically a 2D array, but we're giving them headings and titles. The one thing you need to remember about arrays when you answer them in an exam is that unlike the programming languages that we have used, arrays can only be one data type. That's a really important thing. In fact, I think it might have been a question on the written exam that we had last month. Now, on the left, we have a one-dimensional array. If I want to access maths there, notice we start counting from 0. I would go for subjects, square brackets, 1. That is the array name and the row number. That would access that part. The two-dimensional array on the right, if I want to access Mrs. James, I would access that with subjects 2, 1. Now, notice that's different to the way in which you would think about that in maths or in geography. It is not along the corridor and up the stairs or whatever it is row then column, because what this is in a computer system is just an array with an array within it. So this needs to be remembered. Row then column, and everything is 0 indexed. Here's an algorithm for setting up and traversing an array. The way this works is we'd start out here and we'd work down one row at a time to go from top to bottom. In a 2D array, that works the same way, but we do one row at a time. So we go top left, middle, right. Then we move down a row. Left, middle, right, down a row. Left, middle, right, down a row. Left, middle, right. And that would read everything from a 2D array. Of course, you have to use a variety of data types, including integer, whole numbers, real numbers, decimal numbers, Boolean, yes or no, true or false values, characters, individual letters, and strings, collections of letters, sentences, words. You need to be able to do variables and spot the difference between a variable and a constant. There is very little difference between a variable and a constant. A variable can change in the program and a constant doesn't. We've done scope, we've done lifetime. They'll normally do that with a global and a local variable. Validation, authentication. Authentication is logging in. It's passwords. So it's asking for a username, asking for a password. Validation, just as a reminder, there's a bunch of them. And again, I think this was one of the questions in your exam last month as well. So they may not ask this sort of thing again, but there's a bunch of validation checks. And what they do, the red ones at the bottom are verification. So they check that we've copied something correctly. But let's just pick one. We'll do a range check. That's between two values. And this is what pseudocode for that might look like if you see it written down. It's the same sort of thing that we did when we were looking at the NEAs. It is inputting a value and saying, well, while it's between those two values, then it's wrong, and type it in again. Nice and straightforward, really. But again, you need to know what they are. Okay, the denouement of the evening, the bit you've been waiting for, Greenfoot. Now, first of all, this is your list of things you need to learn about Greenfoot. And this is one of the things that annoyed me enough into creating my video series on it, which took me absolutely ages. Because if you look down that list of all the things you're meant to know, none of them say things like, edit the code for a counter class. None of them say, use a grid that is a specific size with an exact specific size of image. All these concepts are very generic and they're about object orientation through Greenfoot, which is great. But if you had to go and learn that so you could do anything in any way for that, I'm not sure they could run an exam with it. So what you'll find from the Greenfoot questions, past paper ones especially, is that they are very, very similar and they tend to repeat themselves, but they change the way the code is given each year, which is why I went to the effort of reworking the one from last year, 2019. If you want to go and grab this stuff now, please do. There's a Windows and Mac installer of the right version of Greenfoot, a revision sheet, which I'll show you very quickly. This revision sheet here is well worth having for you and taking into school with you tomorrow. It is the samples of code, the explanations, and this is the stuff you need to learn. This is the stuff you need to have memorized for the exam. Everything in the black box there should be memorized so that you can bring it up in the exam time. I know that's difficult. I know that's problematic. And I know this is the bit that most people hate. But if you can get some of it in your head, that would be great. The 2019 past paper, they wrote in the wrong version of Greenfoot. So you could only do part of the questions. The ANTS file here is the 2019 past paper question, but I've rewritten it in the proper version of Greenfoot so that it'll work. If you download that zip file, unzip it, and double click on project.greenfoot, the little Greenfoot icon, you will get this bad boy here. And we're going to work through the 2019 past paper question in a moment. But before we start, just a reminder. In my video series, I've done it all the complicated way. I've done it the complicated way because realistically, that's the right way. Excuse me. That's the right way to do it. But it's the day before the exam. Let's have a look at some cheats that will help you work with it. And I want you to remember this. This is a normal bearing diagram as you get in maths. 0 degrees is up. We move clockwise to 90, to 180, to 270. Okay? Some clever person, when programming Greenfoot, decided that actually 0 degrees was to the right. So you need to remember this as we rotate our characters. We are going to use the cheap method at the moment, and we are going to make sure that we work on the easy, quick to learn bit so we can get through at least half the Greenfoot questions tomorrow. But to do that, you need to remember that we're always going to start with going right first, and we're going to start with going right at 0 degrees. Let's get building. Okay, so here is the past paper question. And the first question is to populate the world with an ant, a water drop, and at least 2 sugar cubes. Now, what I'm going to do is something a little bit different here because they always give you an image of what it should look like. And you'll notice in the top corner, they've already got a counter in there. So what I'm going to do is I am going to make sure, sorry, give me a second. There we go. What I'm going to do is, instead of just putting the things they've asked for in, I'm going to copy that exactly. And that's going to save me some time in the long run, because once I've set it up, I'm good to go. So I'm not only going to put in the ant, and I do this by right-clicking on the ant and going to new ant, putting it roughly in the position. 2 sugar cubes, 1 there and 1 there. And a water droplet in the corner. But you notice they've also got their counter in the top left. And that's what I'm going to do here. Right-click, new counter, and make sure I drop that in the top left. Now, at this point, you need to save your world. The way you do that is you right-click on any of the empty squares, and you click Save the World. Now, you'll notice then that straight away some code has popped up. This is the code for the world, the ground. It's got some code the WJEC have already given us here. They've added that code. Pre-2019, that code wasn't there and you had to memorize it. Chances are tomorrow you may have to have had it memorized again. But in the 2019 question, it was already given to you. This is the code that has been added by me saving the world. And there's just one thing you have to do when this pops up. And that is just to check this code here. At the top, if they have given you this line, counter counter equals new counter, then you can delete it from here. You don't need 2 copies of it. When you've changed your code, do click compile to check it works. And now we've done that, you've got at least a few of the marks, because whenever you run it, this will pop up first. So question 1 is done. We've got a few of those 13 marks. Question B, edit the water drop and sugar cube objects. They turn and move. Now that's important. They need to turn and move. So they need to rotate and move together at random. So that means we need to include random. I'm going to go into my water drop code here because it's the top one. And I am going to do some writing in here. Now, all your code needs to go inside this acts method. So the first thing I'm going to do is go in here and just press enter, make a bit of space in this white box. This allows us to write the code we want. And the first thing we need is to generate a random number. We do that with int, let's call it direction. This is the name of the variable there. Equals Greenfoot. I have to be very careful of the capitalization here. It's very, very strict camel case. And then we're going to do get random number. In brackets, you're going to place in there the amount of numbers we want. Now, because we want our character to move up, down, left, and right, that's 4 different locations. So I'm going to put a 4 in there. And nearly every line needs to finish with a semicolon, which means that it's almost like a full stop. I'm going to click compile just to check that was okay. Brilliant. No errors. The number 1 error you get is this. Reached end of file while passing. What that means is you have probably forgotten or deleted accidentally one of your closing curly braces, one of these things here. If you get this error message, click at the end of your program, add in another curly brace until you see the green line come up, and that will fix it. You might need to put a few in if you've accidentally deleted them. Now, once I've got my random direction, I'm going to use an if statement to work out which way I'm going. So if brackets direction equals 0, because it starts at 0. I need to open a curly brace. Notice it doesn't put an ending one in for me. And this is why so many people get that error. Whenever you open a curly brace, press a few enters and put a closing curly brace in. Try and get in that habit, please, of doing that, because otherwise you're going to find yourself in a position where you haven't got the right amount of curly braces and your if statements don't work together. So again, whenever you put an opening curly brace, press enter a few times and put in a closing curly brace, because it does not do that for you. Inside that if statement, I'm going to do 2 things. I'm going to rotate my character to point in the right direction. Let's start with right. So set rotation. You remember that right is 0 as far as we're concerned. I'm going to put a little comment here, right, just so I remember. And then I'm going to move it. Now, in my videos, I do a big long thing for this, but there is an easier way. Move. It move one square in that direction. Now, with that all together there, that is a code that rotates it and moves it. As that's going right, I'm going to copy that entire thing, and I'm going to paste it below, and I'm going to change that to a 1. I'm going to go down this time, so I'm going to move that to 90. Remember, I'm moving in 90-degree arcs, and that is moving down. The next direction, if I'm going around clockwise, is going to be left. So I'm going to paste that in again. Do this time. Left, that's going to be 180 degrees, and left is done. Final one is going to be up. You get 3. That's going to be 270 degrees, and move. Hit compile to check you're okay. Seem to be all right. If I run that now, you'll see that my water drop has a crazy go and running around my screen. This is where you want to bring the speed down a little bit, because there is usually a mark for the speed being okay. If you save it when the speed is at this level, or for a laugh, you push it right to the top, you are going to lose one of your marks. Bring them down so the game is playing at a reasonable speed. Now, all that code we've written, because the question says do it to the water drop and the sugar cube, I'm going to copy that code. I'm going to go into my sugar cube, and I'm going to paste it in the same place. File it, check you've done that okay, and run it, and everything's moving about randomly. Happy days. I'm bombing through these questions now. Okay. The next thing, edit the ant object so it moves at an appropriate speed in the direction of the arrow keys. This is another mainly copy and paste job. If we open our ant code up, in the same place we put that code, we'll paste that in again. But because it's manually moving, we don't need our random number generation. So I'm going to delete that line. And I'm going to change what's in the brackets, because now we need to check to see if a button's been pressed. Now, as excited as you gamers are about using W, A, S, and D for that, please notice the question says arrow keys. So we need to map it to the arrow keys. So in this bracket for right, I'm going to change it so that the right arrow key is being pressed. Greenfoot dot is key down. And that means, have I pressed the key down? Not is the down key pressed. In the brackets, I'm going to put speech marks in and write the name of the key. That's the right key. I'm going to copy that into the next one. Change it to down. This was the down one. And you can see now why I made those comments in there, just to remind myself. Next one's left. The next one is right. Sorry, last one's not right. That one is up. File, click run, and with your arrow keys, you should be able to move your character around. Please make sure it is going in the right direction. Otherwise, you've misprogrammed it. If they ask you to do a 2-player game, you simply copy that code from this character into the second character and change the keys. The only example they've ever given us of a 2-player game was changing it to W, A, S, and D for the second player. But I've never seen that in an exam question just yet. Okay, so we've done that question here. The next one, this one is the faff. This one is the complicated one. This is the one you need to go and learn a big bunch of code for, because it's a bit weird. We need to set it up so that when the ant hits a sugar cube, it eats it. And what that means is we remove it from the world. So we need to be in the ant code, and we need to be just down here, just after the movement code. And this one's a little bit fiddly because we need to do a couple of things. And the first thing we need to do is we need to introduce the ant to the thing it's going to be eating. The way we do that is we say actor, capital A, and then we write down the name of the actor that we're going to be eating. In this case, sugar cube. Same capitalization. I'm going to go equals there. And the sugar cube I want to find is the one I'm on top of. And this is quite a long one. Get one object at offset. That's a difficult one to remember because there's a lot of parts to it, unfortunately. And what we're going to do here is we're going to add to the bracket 0, 0, which means on top of me. So the character and the sugar cube need to be in the same square. And the last thing I need to say is what type of thing it is. Well, it's a sugar cube, but I need to add one more thing to that just to get it to work. Dot class, because these are classes. So what that's done is it said, right, if I'm on top of a sugar cube, I'm going to make that sugar cube equal to this variable name. Brilliant. Our next thing to do then is to set up an if statement to what happens if I am actually touching a sugar cube. Now, where the ant is now, this value of sugar cube is null, as in there isn't a sugar cube that I'm touching. When it lands on a sugar cube, that value becomes something. It becomes the sugar cube it's touching. So the if statement is reasonably easy. If sugar cube is not equal null, I'm going to open my curly brace, and just like I suggested earlier, I'm going to come down and put a closing curly brace in. So I've got some space to write in. I know that's okay. Two weird things here. And the only way I can get the ant to remove the sugar cube is by talking to the world. The world is the thing that manages the objects in it. So what I need to do here is I need to tell the ant what the world is. So we need to start off with a class name of the world. Our world is called ground. So I'm going to do capital G ground. And this is when it starts to become a bit confusing, because you need then to give the ground a name. And what the exam board like is this. So ground, capital G, is the class name. Ground, lowercase g, is the name of the piece of ground I'm on. Confusing? Yeah, it certainly is. And the way we're going to get that is we're going to put in brackets capital G ground, and afterwards get world. What that's going to do is going to get the world I'm in. It's going to make it a piece of ground and set it to that variable. So I can now talk to the world with the lowercase ground. I can say ground dot and then remove object. So take something out of the world. And in the bracket, I name the object I want to go. Well, that's sugar cube. Pop that in there, and that should remove it. This is the bit that's the hardest to remember, because there's loads of code here and there's very little help, and some of it's a little confusing. You just need to go over that, over and over that in your head, okay, as much as you possibly can. If I run it now, I get my ants onto the sugar cube, you'll see that they disappear. Now, in my cheat sheet, I've got the code to respawn something if you need to do that. It's broadly similar. It's adding the object back into the world at a random location. I'm not going to do that tonight because we're already about 13 minutes over and I don't want to spend all night doing it. We've never seen a question in an exam that asked you to respawn, but they could do it because it is in that specification. The next thing you need to do is play a sound. Well, playing a sound's dead easy because they always give you the same sound. Inside that if statement, because we want it to happen once I've removed it, Greenfoot dot play sound. I know, crazy. And what we're doing here is we are going to put the name of the sound file in speech marks. It's always been pop.wav, always has been. But in your Greenfoot folder, there'll be a folder called sounds. Just double check in there that there's a file called pop.wav. Otherwise, you will crash. So I compile that now and I run it. When I'm doing that, I'm hearing a popping noise, which is lovely. Really high quality sound effect, that is. All right, the last thing is the counter. So in this case, I'm going to add a counter, edit the code to the counter displays how many sugar cubes have been eaten. I've already added the counter. It's in there. I did that and it was my first step. I was copying what this looked like. I'd suggest you that first because it's much easier to deal with. I now need to edit the code so that the counter displays how many sugar cubes have been eaten. In ground, at the top, I have these two chunks here. Those two chunks are on the cheat sheet, telling you how to go about putting those in. In previous years, in all previous years, you've had to write those yourself. In 2019, that code was in this file for you, so it made this step much simpler. But do make sure you know this stuff, because you could end up having to write it yourself. Let's keep our fingers crossed that you don't. Now, what we're going to do is very simple. We are going to use inside our if statement. Once we've taken that sugar cube, I want to add 1 to the score. Now, the way counter works, if we double click on it and have a look at the code for it, wherever that's gone, here we go. This is the code for counter. Counter works by having this function called bump count, and they do sometimes change the name of this. So it's well worth going into this file and just checking what this function's called, because it's been bump count, bump counter, bumper count. They change it sometimes just to be annoying. It tends to be bump count, and in the brackets, we'll give it a number that tells it how much to change the counter by. Back in our ant, let's see if we can get that working. Let's make a counter. Capital C counter, and then a name. Again, lowercase c counter. Need our world name, which is ground, lowercase g. Get counter. Now that is a reference to this bit of code here, which will send the counter back from the main world. So that's us getting the current value of the counter. The next job is to tell it to go up by 1. Counter, lowercase c, bump count. Ooh, do it. I'm going to put a 1 in there because the question's asked us to increase it by 1. Compile it, check it works. I've forgotten a semicolon at the end there, and you'll notice that the error message is actually quite good for that. Hit compile. And when I run it this time, as I eat my sugar cubes, do watch that the score has gone up. How'd you like them apples, WJEC? I'm joking, of course, but this was the question that in the 2019 past paper didn't work. If you download the files from your teacher or from the WJEC website, this bit won't work because they did it in the wrong version. I've rewritten it so that it works for you. The very last thing is we're editing the code so the counter loses a point if the ant collides with the water drop. Well, this is reasonably simple. This code here is everything we need. So we're going to copy it, make a bit of a space, and paste it. Now, it's not a sugar cube we're dealing this time. It's a water drop. I'm going to go through and just change that. I don't need all this code because I don't need to remove the water drop. It's not asked me to. I don't need to play the pop sound. I'm getting rid of those two. But instead of increasing the counter by 1, I'm going to set it to -1. So it goes down by 1 if I end up on the water droplet. I'm going to click compile again. So now it's saying, if I'm on top of a sugar cube, remove it, add 1. If I'm on top of a water drop, take 1 away from my score. And if I run this now and try and hit the water droplet, you should see, I'm eating sugar cubes instead, very helpfully. But there we go. Hopefully, working brilliantly, as you can see. So let's have a look at what I've done wrong here. Here we go. I didn't change this side. So you've got to be very careful because even I can make that mistake as we're going. And I've done this a million times even today. Compile that again and check it runs. And if I go to my water drop now, I should be able to get, there we go, into the negative numbers. It's quite hard. There we go. I'm in -1 now, -2. You can see that it's actually working this time. So that's that code. Now, here's the bit you need to remember to do at the end. When you are done, or as done as you can be, and it's working, it does say to save your completed world as this. So you do need to go scenario, save as, and give it this name. The chances, sorry, it's final ants 9. The chances of you having the file called that in the first place are low to small. Now, I'm not going to lie to you. Once you've done this Greenfoot question, you will never need Greenfoot again in your life, and you can promptly forget it. And I would encourage you to do so because there are many better object-oriented ways that you can learn to program something like that. But I imagine that from this revision session, most of you will want to go and do a bit of Greenfoot revision. That's fine. I understand. At the end of that web page, there are 3 things you want. There's a 2019 past paper work through, which is me working through that 2019 past paper. I'm doing it the long way. You could go and watch, the VOD for this, which will be available almost straight away afterwards. Or there's another walkthrough here of another scenario the WJEC have given us. Sorry, 1 second. There we go. This Ocean's 11 scenario has a bit more to it. I think there are multiple characters. a lot of collision detection and some different ways of asking the same sort of questions. So that's a good one to look at just for differentiation. And of course, there's the full Greenfoot tutorial YouTube playlist with my Pirate Island theme, which most of you have done a million times already. But at this point, it's about making sure it works properly. The cheats of how to do it with the setting the angle and moving it is valid and will give you the marks. It just means that sometimes the images of the characters might be a bit weird looking. So, topics done. But before we go, last 10 minutes, I want to have a quick look at the random questions on the 2019 past paper to show you what they were like. Here was a question that was worth 4 marks. And the question basically says, look at this code on the left and identify a line of code for a local variable and a global variable. Well, a local variable is a variable set within a subroutine. There's me setting a variable in the subroutine. That's a local variable. A global variable is me setting a variable outside of a subroutine. There's me setting a variable outside of a subroutine. Annotation is a note in plain English. There's a note in plain English. Assignment is making something worth something else, so something equals to something. There's a bunch of them. You could have picked any of them. Most people that have done that there, most people that have attempted that question got about half marks and got a bit confused on the assignment. Everything else was all right, usually, just having a bit of a guess there. Then we've got this question. This one has been done poorly for ages, okay? Absolutely terribly. Because it is basically a for loop within a for loop, and you had to fill it in for this amount of iterations. Let me show you how this would work. So if we start at the start of the loop, we're going to make I set to 1. So let's bring I in. Now, every time we come up to this part of the loop, we're going to increase that one more time. So we've got I as 1. The next line is we're starting another loop with J. J is going to start at 1 and go up to 3. We're going to work out the output value, which is I times J, which is 1 times 1, which is 1. Then we output the value. And when we output it, it's going in that column. So 1. Where do we go next? Well, we're in the middle of the J for loop there. That's the one we're in. So we're going to increase J. I times J is 1 times 2. Let's put it in the table. Still in the middle of the J for loop. That's going to go to 3. 1 times 3, 3. Stick it in the table. We've done the J loop now because we've done 1 to 3 on J. So we go back up to the I loop, and that needs to increase to 2. We go back down here, and J starts again at 1. We're talking 2 times 1 here, which is 2, and that gets output. J increases to 2. 2 times 2 is 4. Slap it in. J increases to 3. 2 times 3, 6. Slap it in. And then J is done, so we're going back up to I. I becomes 3. J resets to 1. 3 times 1, 3. Goes on the board. J increases to 2. 3 times 2 is 6. Goes on the board. J increases to 3. 3 times 3 is 9. Goes on the board. Now, annoyingly, this question, which was all about trying to read code and interpret it as best you can, had some bad marks. And it had bad marks from people that sort of knew what they were doing and were trying to work out the answer. If you didn't know what you were doing, some people just wrote 1, 2, 3, 4, 5, 6, 7, 8, 9 in the column and hope for the best. Annoyingly, those people would have got 4 out of 8 because coincidentally, 1, 2, 3, and 9 are in the same place. So this was a weird question, whereas if you knew a bit more about it, you would have struggled with it. Okay. This random question. Where in the Greenfoot file would you find these things? Well, first of all, a superclass and a class. The superclass is the name of the types of classes, and a class or subclass are the different kinds of classes underneath it. So a world is a superclass and the ground is a subclass. Same with actor. Actor would be a superclass, and any of the characters would be a subclass or a class. What about a private property then? Well, property is data. It is data being set, not code. So we're looking somewhere for something like an int that's been set to private. Well, there's one there. Copy and paste that line. A lot of people actually got those marks. They were just looking for the word private in the code. Comment. Well, there's one there. And a method, which is automatically run in each frame. There's only one of these. In Greenfoot, the act method is run every frame. So when you're changing that speed, you're changing the amount of times we run the act method per second. And of course, those of you big gamers out there will want this to be 60 frames per second. Now, good luck for tomorrow. That's everything. We've been 1 hour and 26 minutes, and we've managed to cover every single thing that we could possibly want there. We've covered everything in the specification. We've covered everything in that list. But it's a lot. And I'm sure the thing that most of you are worried about is Greenfoot. So once again, just a reminder, if you go to this website, lessonhacker.com/unit2, I've collected all the resources there. It's the same resources that I've given to my class for in Google Classroom. So you can go there if you want my class and grab things from there if you want, but they are organized in the same way we've done tonight. The VODs will be available straight away after. I will also download them and put them on Google Classroom so we can access them from school tomorrow for those of you coming in. And I will try and be in my classroom as early as I can tomorrow so we can have a bit of revision before the day actually starts and the exam starts. Now, we do need to remember that the exam is going to be 2 hours tomorrow. You're going to be in your computer rooms. Prepare yourselves for more like 2.5 of controlled time, and try and use it appropriately. Time-wise, what I'd be trying to do myself is that I know that Greenfoot is what drives everyone mad, and the exam suggests that you leave 1 hour for Greenfoot and you do everything else in the first hour. I'd be trying to get the first part done in about 45 minutes. So you have a bit longer for the Greenfoot. The questions do take a bit of time, especially if you're trying to remember the code or you're getting stuck on it. But it's not the end of the world. If you can get as far as moving the characters around randomly and with the keys, then you are about the half mark stage on the Greenfoot questions. And at that point, then you're good to go. Well, the chat has been exciting tonight. I've been purposefully ignoring it, as you can imagine. So apologies if there was a bit too much going on there, but hopefully the majority of you have got something useful out of this session. My classes in particular, you know what you're doing. We've done this a lot. If there's one thing you practice tonight, practice the thing that you're the most worried about. And if it's Greenfoot, do it. And if you're concerned about memorizing everything, get up to the point where you can move the characters. And anything past that will be lovely. But just do what you can and get the marks you can. Remember, everyone in Wales is in the same position. We've had interrupted learning. We haven't been in our computer rooms. Everyone's in that exact same position where we're not as confident as we could be for this exact exam. Go do some revision tonight, but most importantly, please do make sure that you get a good night's rest, because it's much easier to think clearly when you've had a decent bit of sleep. Good luck tomorrow. I'm sure you won't need it. I'm sure you'll smash it. But as long as you do the best you can, that's all I can ask for. Bye.